Hey everyone, welcome to a very special deep dive. Today I have with me Jay Rush, who's kind of a longtime friend, and he's building out Trueblocks. Thanks for coming on, Jay.
Sure, I'm very happy to be here. It's great to see you again.
Yeah, I mean, this is going to be kind of a different one. Usually I do deep dives on like Oracle solutions or bridges and I whiteboard them out, but you're actually building something pretty different. Like if you had like, what's the like quick pitch as far as what TrueBlocks is, that you've been working on.
Sure. So I'm going to say it's indexing,
Okay.
uh, but not indexing in the way that most people do. Most people do what I call a full extraction of the data. So they take not only, I take a minimal amount of data off the chain to do the index. They take every piece of data off the chain. And that's the distinction between what we built and what most people are building. So we did that very specifically because we wanted small data. I wanted the smallest possible data so it could be on a small machine.
Yeah,
So
so I mean, I think like indexing is a different problem than a lot of people are probably aware of, just in terms of like what was the original problem? Like why did you start solving this and what was kind of the issue that
I'll
led to
tell you exactly, I know exactly where it was. It was, a week after the Dow hack of a perfect accounting system that has 18 decimal place accuracy. Three different people wrote posts saying, here's what happened. And all three were completely different. And I'm like, why in the world does a perfect accounting system have no ability to actually know what happened, what the history of the hack was? And it turns out that I think it's because the indexing is not there. So people were doing, they pull data from the chain, um, but there's no real index of every transaction for a given account. So they were getting different lists of what happened, different lists of transactions. And of course, you're going to come up with different results if you have three different lists of transactions. So the question was, why did that happen? How did that, what was the problem there? And it comes from the fact that there is no real indexing in the chain.
so I think like like most people who would be aware would just say like, well, there's Etherscan. Like
What the hell? I mean, that's insane. That's literally insane. Yeah.
so why is that?
Well, I mean, why not just use Google? There's also Google. We can have Google's way more capable than Etherscan is to build a block explorer.
So
Let's
you
just,
just mean Etherscan's not decentralized, so we need our own version versus trusting Etherscan, correct?
it's not even mildly decentralized. It's not even trying to be decentralized. And because they took every piece of data. Wow, talk about deep dive. We like really went right into the deep dive. That's good. Good. It's good for me to go right into the deep dive because I literally have no ability not to go into the deep dive. Um, they pull every piece of data. They take the chain and they extract everything from the chain. Transactions, blocks, traces. They try to get traces and everything, which creates this massive database that they have to maintain. Okay. But then what they do is they can't really maintain the size of this data and deliver it to, 100,000 people. So they kind of cut down on what they'll actually give you. For example, they don't give you more than 10,000 transactions on any address. That's fine. That's fine. It's their choice. They can do that. They have to do that. But to me, that's like, why? Why do that? Just give me the chain itself and I'll index it myself and I'll get every one of those transactions, all 100 million or, all million of them for some of the addresses. So the fact that Etherscan sits in the position that it sits and it can make decisions like, I'm not going to give more than 10,000 addresses is exactly wrong. It's
Right.
exactly wrong. Because what we built with the chain is a thing that anyone can run, supposedly, and anyone can access the data, supposedly. And it's 18 decimal place accurate every single transaction. So why then do three different people do an analysis and get three different answers? That's where Trueblocks started. It's like, why does that happen?
Yeah. I mean, before I start drawing it out, like why is it, why is this verifiability important as far as like everyone can run a node? Because like this is, I know super fun caveat, but like in talking to Jay Rush on this episode, he said like, I'm happy to talk about anything Trueblocks, but just don't ask me about any of this recent stuff within the past 2 years.
We're supposed to tell people that, but
Yeah. Well, it's just super funny because, like it's coming back to this, like with everyone else is out there and, there's all these roll-ups and these, chains with, terabytes worth of data every second or whatever. And everyone's like, well, why do you need, why does the home computer need to be able to verify it? Why do you need to sort of have nodes that people can run on their own machines or even validators?
because what ends up happening is that these things become super valuable, right? A system that runs an economy is unbelievably valuable, right? And if the access to that data is owned by a company or by a small group of people, um, or even a large group of people, over time, it consolidates into a small group of people. And this to me is exactly what Bitcoin solved. This is exactly what Bitcoin solved was um, they incentivized people to run software that distributed the data. And by allowing the system to get recaptured by a small group of people, we're literally just defeating exactly what a distributed system is supposed to be. To
Totally.
me, now you can have people saying, I'm a good person. I promise you I'm going to give access, but they can't. It's not that they don't want to. It's Etherscan cannot give me more than 10,000 records because they have, hundreds of thousands of people hitting against their server. And they're incentivized to give, um, I as a user am incentivized to want all of the data, and they're incentivized to give me just enough to make me happy. So where we have totally different incentives. And that to me is what Bitcoin solved was get people to run nodes out on the end so that the data is distributed.
Yeah. What
And
do you have?
if we're not building that, I have no idea what we're supposed to be building. I don't.
Well, I mean, you have that discussion with Bitcoin right now because like there's kind of like several points of centralization kind of going on right now. Like, like I just retweeted a post today that like 55% of blocks on Bitcoin were built by two people. You know, and of course, like Bitcoin, you have the ability to verify all of the data because it's, they haven't upgraded in years, so it's still relatively small. But at the same time, like the mining is getting more and more centralized, and like with Ethereum, you have like maybe less people in charge of 55%, but there's like centralizing forces with the data, with the
I don't want to sit back idly and watch that happen. I want to speak out loudly and say that's not a good outcome because in the end, 20, 30 years from now, seven companies will own the entire world's economy and
right.
they can shut it off. They can filter it. They can withhold it. They can charge us for it any amount they want because we need it more than, we need it. So, you know, it's true what you say is that, but that's exactly what I'm not giving into lightly, right? I realize I was 55 years old when I got into blockchain. Okay. So I'm like, 10 years away from retirement or something at 55. That was 7 years ago. And I'm like, I can build something that doesn't make sense. I could have built Etherscan, back then. And I'm like, I'm not doing that. I want to build fully decentralized and really understand what that looks like.
Yeah. Well, I mean, what was kind of like it's cool that you kind of found that to be a problem back then because like I remember back in what was this 2016, um that was still like the mist browser days, right? Like like
Oh,
how
100%.
how were the vision back then was very different. Like what was kind of the Ethereum vision and like how has it changed kind of or at least
Sure. It's so interesting that you mentioned the Mist browser because that's basically that was a they when they wrote that code and when they wrote the node software, the first time I ever used Ethereum, there was no remote RPC endpoint. You would start the Mist browser and it would complain about not being able to find a node endpoint. 8545. And I even wrote a post that's pretty popular on Stack Exchange. I'm like, what the hell is 8545? I have no idea. And that was because the software Mist would start up and want to see a locally running node because that's exactly how it should work. I should be able to run access. I should be able to get access to this massive data without asking permission from anyone. I'm running my own access. And then Infura comes along because that was such a pain in the ass. It was like a major pain in the ass to run your own node. Infura comes along and solves that problem. And I remember back then, I'm like, don't do that. That's not a good idea. Because what happens is everybody now uses Infura or some remote RPC endpoint, right? And these things are consolidating. They're getting the number of people that are doing that are lessening and lessening. And quick nodes is a good example. In Fura, there's a couple. But 15 years from now, there'll be one because there's who's going to ever sign up for the second best RPC endpoint? No one. Every single person that comes signs up for the best RPC endpoint. And then you get one RPC endpoint provider, and now you have what have you built? You built a really stupid system, in my opinion. So back in the day, it was exactly right. You would start a browser, a Mist browser that would look for RPC 8545 locally. And I kind of guess that's what I'm saying. But I'm saying let's not give that up because that's how it should work.
yeah. So I mean, let's get into kind of what you're building. I mean, the original problem was just, okay, so like if people are running these nodes, the problem is that you have an address, say, my address, and I want to see all of my transactions, right? And that's actually pretty hard to do in Ethereum, right?
It's nearly impossible.
Right.
It's nearly impossible without an index. And this is exactly the index that we built. I built the index that solves exactly that problem. I want to see, it's not just every transaction, it's every time the address appears anywhere on the chain.
Well, because the problem is like if you get sent tokens, that doesn't actually come from
Oh,
your address. That's
which is exactly why these three things, a week after the hack were different because they were doing a different method of finding those internal, we used to call them internal transactions. It's basically when your address is used as data. So your address is not a participant in the transaction other than its data in the transaction. And it appears basically in the input data to a transaction. So what we did is we kind of just look inside that input data for addresses.
right.
And it's technically impossible because, I mean, it just is because people can take an address and just pack them right next to each other. And now they just look like a string of bytes. So I can't find that address. I don't know that that's an address. But what Solidity does, it packs addresses with 12 leading zeros. So
So that
what we Yeah, so we just scan the input and we find addresses we find bytes that have 12 leading zeros, and we say that's probably an address.
right.
And then we put it in our database as an address. And if it's not an address, no one will ever search for it. So it's fine. There's no problem. but we want to be more inclusive rather than less inclusive. So we say that looks like an address. That's kind of why I call it an appearance. I don't call it a transaction. I call it an appearance because it appears to be an address. And that's the index we build. And we only build an index of addresses. So when you ask Trueblocks, where does my address appear? I give you back a list of transactions. That's the only thing we do.
So I mean, so you guys have like, you have a user here and he has like 0x123 as his address. And if let's say he wants to know all of his transactions, right?
Appearances. I would call them appearances.
Appearances. Okay, so would he start up his own node? Is that a requirement in doing this?
Well, that's a hard thing to ask people to do, obviously. Yeah. Slightly difficult thing to ask them to do. So in the best of all possible worlds, he could start up some kind of node software that would give him access to everything that he's running and he's in control of, and that the system would allow him to query any transaction.
So he can either run his own node or he would probably put on RPC, correct? Or
He can use a remote RPC, but the difficulty there becomes immediately that RPC is shared with hundreds of thousands or 10,000 people.
you're going to
So
get rate limited.
you immediately get rate limited, especially for big addresses where you have, a million transactions or something. So I purposely built it against a locally running node because I wanted to eliminate that rate limiting problem, because I wanted to solve the problem of finding every transaction. Okay. If I had tried to do that with a remote RPC, I would have pulled my hair out because it was just too slow. But that's another thing that I want people to understand is if you do take the pain of running a node, the access is literally, it's 1,000 times faster because first of all, you're not going over a wire. You don't have to go over a wire to get to the data. And secondly, it's not shared. So it's not rate limited. You have your own access. So when I go to look at teller's address, for example, you have a lot of transactions, I can look at my index. It takes like a second or something to find the list of all the transactions. But now the node software becomes really nice because I'm not scanning the history. I'm actually picking exactly what I want from the node, and the node becomes a pretty good database. Whereas without an index, the node sucks as a, which is why MIST didn't work. MIST kind of didn't work because the node sucks, and it sucks because it doesn't have an index.
Sure. But Mist would have been great with an index.
It would have been, no, because that's what, so now I have this index and now we're building local applications, right? And they're 1,000 times faster than a web-based application where you have to ask for a page at a time. I don't ask for a page at a time. I don't ask for 40 records. I ask for 40,000 records.
Yeah.
And it comes back as fast as a page. So the kind of application that you can build when it's truly decentralized, both the node and the application, it's just a completely different type of application. And I always knew that asking people to run nodes was going to be it's an insane thing to do. It's like everybody looks at me like, what the hell are you talking about? I always knew that, right? But I also knew that it was going to be an amazing application once I could build it. And I wanted to build it so I could just show people what I'm talking about, right? And we're pretty darn close to getting to where we're actually working on front end and sort of, I don't want to call it mist browser. I don't want to say that, but it feels like what we all thought that might look like.
What are you calling it?
I just call it browse. I don't call it mist. I thought about calling it mist, but I don't want to do it.
All right.
So yeah, but I was telling somebody last night that so I never would have built this thing if I had used a remote RPC. couldn't have done that because um, it would have taken me 10 times longer for one thing because it's 10 times slower or 100 times slower. So now that I've built it, now we're actually saying what parts of this thing can we put out on an API or a web thing to try to give people this type of access where they know exactly what their transactions are, without requiring them to run a node, which is hard to do, but we're trying to figure, we have some people that have done that. Some people have done it, run against a remote node, but we have to kind of seed. They can't build the index themselves, which is the provably true part of our work. The fact that you can run the indexer locally on your own machine against your own node, I claim is provably true. It's like, it's open source software. You can read it. It does exactly what it says it does. So you're building your own index. If you're doing a remote RPC, you can't do that because you have to hit it so hard. So it rate limits you immediately. So we have this seeding thing where people can download the index so that they have it, and then they can just build the index as the chain progresses, and they can easily keep up with the chain. They can't build it from scratch, but it's just, so that's sort of a compromise thing that we've done. But
Well, I remember you used to do that with whole chains. Remember that you passed around like the bootstrap.dat file
yeah,
and
exactly. Right.
on a sync.
So this is just the index. It's just the index, like a bootstrap thing.
Yeah. Well, I mean, and then how does this relate? So like you can pull this and obviously you can store it in your own machine, but I know you guys do things like with what is it, the Unchained Index as well. How
Right.
does this relate to that? If you
Right.
could explain it.
Right. So this is another thing of like provably true data, where we're going to create data that can be reproduced, and that's true with a chain. You can read the chain. You can do an algorithm on the bytes that come back from your query. When we query a block, we read all the data in a block and we extract addresses, with how I was talking about earlier, where we look through the input data and we find all these appearances. And that is reproducible. So any person who queries the RPC can come up with exactly the same list of addresses that we come up with, right? Because they just run the algorithm. And now we want to share that data so we don't become the holder of the data. We don't become the bottleneck or the gatekeeper to the data. I want to publish this reproducible data in a place where any human on the planet can get it
Without having to run a node.
without having to run a node.
Right.
Now, they do need access to IPFS. I mean, technically, you could say they have to run an IPFS node on their machine to download it, but there's IPFS compromised with this idea of a gateway for IPFS. So it's kind of a server, it's basically a web server. So what we do is we build this reproducible data and we push it to IPFS, and then we push the location of all this reproducible data to a smart contract.
So like this person would say like, would this be everyone's transactions or just his transactions that he would push?
What we push is everyone's transactions for like we scan the chain from block 0, and when we get 2 million appearances, which is just an arbitrarily chosen number, we get 2 million of them. Then we create what we call a chunk, and that's a reproducible piece of data, and we can put it in IPFS. So now we get a hash.
Okay, so you put it in IPFS and it gives you a hash.
That's right. And then we store that hash in something we call a manifest.
And that's a smart contract.
The smart contract, we put the manifest also in IPFS. The manifest is just a JSON file that has the list of all the hashes. Each time we get 2 million records, sorry, this is crazy. each time I'm going to send a link that people can listen to me talk about this in a presentation I gave, and it's much, much, much clearer.
Okay. And then you push the whole manifest.json to Ethereum.
IPFS as well, and then we publish the IPFS hash of the manifest to the smart contract.
Okay.
And
How,
then what anyone can do is read the smart contract, download the manifest, which includes a list of the hashes of all the chunks. And now they have access to every chunk.
right.
Okay. And now they could download every chunk if they wanted to. And now they can scan those chunks and they can get a list of their own transactions wherever their transactions appear.
So how is it verifiable in the sense like is this a trusted push that you guys have pushing it here?
Well, it's reproducible
Right.
first. So anyone who wants to can have a node and reproduce this exact hash. They would get exactly the same hash. Um, it's trustable in the sense that once we push it, anyone can verify it if they choose to. Like we can't stop them from verifying. Um, I can't think of a way to. I mean, I don't even think it's necessary to have a mathematically provable truth. Okay, I thought long and hard about how to do that, and I conclude that it's not necessary. It's almost like here's my attitude towards it. It's like it's not my problem. I'm producing this data because I need it for my applications. So it's as true as I know how to make it. If you want to verify that it's true for yourself, all the tools are there for you to do that. And it is absolutely not my responsibility to do that for you. And I think that this belief that we all have that you have to mathematically prove that it's true is not necessary because it puts the responsibility for the truth on the wrong person. It's not the responsibility of the provider of the data to prove it. It's the responsibility of the consumer to prove it. So our smart contract is actually permissionless. So I can publish this hash, and we record in the smart contract my address as the publisher. So if you believe me, you can go and check my work and believe me. And then in the future, you can just continue to believe me if you want to. If you don't want to do that, download a node, run the software, build the thing yourself. That's what I say. And then because it's permissionless, anyone can publish a hash. So I would love to see 500 people producing this data. They're all producing the exact same manifest because they can all run it, they can all reproduce it, they can all publish to a smart contract. And the smart contract records 500 instances of the same hash being published by 500 different publishers.
Yeah.
And then
You should use Teller.
I don't know how to use other people's software.
No, yeah, I mean you would just use an Oracle. So like the Oracle method would just say like Teller's like probably the simplest Oracle out there. You stake some money, you publish it. If somebody disagrees with it, they can dispute you and we vote whether it was true or false. And then it's like
So you're offering a grant?
man, we're not that rich. I don't know. We'll have to talk about those grants though. I saw you in the optimism round.
Yeah. Yeah. Yeah.
Yeah.
I know what you're saying.
Yeah, no, but I think like it's cool because like most people would say like why are you publishing this in a smart contract and not just opening it up via an API if it's trusted like that.
Well, because I want to give permissionless access. Because if it's an API and some guy comes along that I don't like, I can say no. But
Right.
if it's a smart contract, any person on the planet can read the smart contract and find this data as long as it's pinned by someone, right?
Sure.
So the other part of our work is like when someone downloads using our system, they don't just download it to their own machine, they download and pin. So the more people who download, the more people that hash is distributed to.
Right.
So it's now here's the obvious thing. It's freaking complicated and it's crazy and it's odd and it's unusual and it's kind of what happens when you really want to decentralize. Like, yes, it's true that I could have put all of this up on an API all over the place, right? 20 different places in this system, I could have put it on an API, right? Um, and that wasn't interesting to me. I just didn't want to do that. I just wanted to see what it might look like if it didn't do that. So we did a presentation where we said, this literally is an API, basically. If you have an RPC endpoint, you can query the RPC endpoint for the smart contract value. And it's literally, it's kind of looks like an API to me. I'm just querying some endpoint and I'm getting some data back. It comes from a smart contract that can't be changed. It comes from IPFs that you are guaranteed that if you pull that piece of data, you get what you're told you're getting. And it's reproducible data. So it's like I tried to get as close to ground or something, as close to like just creating something that anyone can reproduce and I can't keep, I can't hold back. And this is what we came up with. I'm not necessarily saying this is how it should or shouldn't work. I'm just saying it works,
Right.
and when you get this index down on your own computer and you have a local node, you get a piece of software that's literally the furthest thing you can imagine from a web application. Because there's no pagination, there's no one page at a time, hit the next button. It's just 40,000 records all in memory. And it's more like a spreadsheet than it is like a web application to look at your history.
Sure. So I mean, like, how do you think we get there? So like there's this idea, like it almost sounds a lot like the Urbit sort of vision of the world in a lot of ways, as far as like everyone sort of is downloading their own data, verifying it on your own machine and running it. But it's like it's a ways away from being there in the sense that people are generally lazy and don't want to run your own node, or like now it's just a
I,
very
I know exactly what you're saying. Yeah,
yeah.
absolutely.
How do you get there? Is it going to be a social phenomenon? Is it going to be something
No,
push?
no, no. I think you push and pull. Okay. In one end, you show people what an application would look like if you had local data. And you say, all of the weird shit that happens in a web application, and in particular, I get 20 records at a time, or I get cards where I see these little things or something. All of those things are tricks that web developers have to do because they can't deliver a lot of data to the application at once. They just can't. Um, pagination is a form of rate limiting, really. It's like I'll give you 5 records at a time, or I'll give you 20 records at a time. So you show people what it looks like to have an application that has instantaneous access to 100,000 records. And you build an application that's compelling enough to convince people to be interested in that. Okay. That's one thing, but that's never going to be enough because people are lazy and they don't really do things outside of the system. Like whatever system they're working in, they just take what they get. So I think that's why it's so important that I think the node software has to have indexing in it. And I think the node software has to be able to be run on a desktop computer. I think it has to be, in fact, I think it has to be installed in the operating system so that when I boot my computer, you know, it's running a blockchain node. And when I open my applications, it's getting data from my blockchain node.
Well, I mean, there's also this general push and pull, like we're obviously seeing like the UX battles in place whenever it comes to like people always talk about transactions per second, That's why Solana is doing great and everyone wants to move to a roll up and like it's obviously a trade-off whenever you think about it in this sense though, because the faster you make your blockchain, the more data you're going to have and then the less likely you are to be able to run on
Well,
a desktop.
I completely understand. I don't think that this desktop version of the node that starts up when you boot your computer will ever have all of the data. And it shouldn't have all of the data. What it should have is access to all of the data. It should be able to get any piece of data without permission. It doesn't have to have it all locally on its own hard drive, but it does have to have access. And that's one of the reasons why IPFS is really interesting. Because if the whole world, if every computer is storing its own data, its data, the data for the user, plus maybe 10% or 15% more than it actually needs for the user. So you're storing everything you need plus a little bit more, and every computer does that, then access would be available to everyone because everyone's serving, everyone's consuming.
Yeah,
You
this
know,
is, I think you'd like Celestia in a lot of ways. If you know, they do data availability sampling, which is,
yeah, I mean, it's important. I think that's how it has to be because if it's not that, what is it? If it's not that, then you have to ask permission for access to the data. And as soon as you have that, you have people that are going to be have differing incentives. You know,
so
they're going
in your world, you would have basically people are pushing it to IPFS, kind of
the
the index.
system, not people. The system literally pushes this data to IPFS. It's available in IPFS. The trouble with that is that you might drop a piece of data somewhere, right? So some person might have some important piece of data and their computer dies and they die in a horrible plane crash or something. Right? So you have to have redundancy. You know, I don't know how to solve that problem. It's a complicated problem, but I think that it has to be that way. Otherwise, you end up with data providers who are going to just take advantage, and we're going to end up worse off than we were before because we've laid our entire, civilization on top of this thing that can be controlled by Google or something. I
Right?
think that's bad design.
And wanted to ask you too, like about how do you sort of see privacy fitting in here? Because this is it's very important as far as is there sort of a trade-off between privacy, verifiability, and transparency? You know,
Well, let's just imagine that we have a system where Etherscan is the only way for you to access this data. Okay. And it's purely public data the way it is now, right? The chances of Etherscan not selling information about all of these addresses to people who are interested are zero. So Etherscan becomes, a data seller, right? Of public data, right? And then we all say, oh my God, that's horrible. They're watching my transactions. We have cryptography, so we can solve this by making all these transactions private.
yep.
But now we've just destroyed the business model of the single entity that controls access to all of this data, right? So they won't do that. The Etherscan, who's giving us access, will say, we're not going to change the way the software works. We're not going to give you privacy. No way. Not going to happen. So again, you come back to you have to run a node locally because you run a node locally. That's the only way you can ensure that you're private. And maybe it becomes pure peer-to-peer where I interact with you because I want to give you a private message that includes some coins in some way or something. I don't know exactly how that gets translated into a fact that Nick owns those coins or something, right? Um, I haven't seen how that might work, but I feel like if you're not running your own node, you're at the mercy of whoever's running the node, and they're not going to change the software to be private because they're kind. They don't give a shit. They're gonna make money off of your lack of privacy.
Right.
So, and that goes against Solana growing a 10 terabyte a week chain, right? They're one person's running that chain or something, or 10 people or something. So yeah, it's a hard problem. I don't know. But I really truly think it comes down to running a node. You have to run a node. We just have to run a node, I
Yeah.
think. It doesn't have to be a node that contains the entire history of the entire blockchain. In fact, it never will be that. It has to be something different than that, but it has to have access and quick access.
Right.
What
Yeah.
do you think about privacy?
No, I was just thinking it's sort of tough in a lot of ways because you can identify things whenever it's public as far as holding people accountable. Like we had gone back to talking about Bitcoin miner centralization, and we know it's an issue, and we know it's something that we should be addressing, and hopefully they are. But if it was actually private, it could be 95% all one company, and you
It's
actually have
true.
no idea.
Well, yeah, I think I didn't say that earlier. I think that both things have to be true. You have to be able to be perfectly private if you want to be, and the users of the system have to demand that things that need to be public are public.
Right.
So if we run our government, let's say we run our governments on top of blockchains, like the law, the writing of the law. If that's private, we are screwed beyond belief. So, our governments have to be, and the people have to impose on the governments, you're going to use a system that is perfectly transparent,
Yeah.
right? You can't use privacy for certain, maybe there's certain things you carve out, um, but that comes from the people imposing on the governments. The governments are never going to agree to that if we don't impose on them. But you also, at the same exact time, have to have the ability to do privacy perfectly. You have to be able to be perfectly private. And both of those things have to exist on the chain at the same exact time.
Yeah. Well, I mean, I know one area I wanted to bring up that I know we may have some disagreements on would be, like this is obviously great for interacting with Ethereum, and if you have an Ethereum browser, it works. But in a world of thousands of chains, no,
Yeah, yeah,
you're
no, I
shaking your
hear
head.
you.
How do you do
Well,
it?
again, so I feel like the people, the
Yeah.
regular people, the users, they can't be lazy and they can't just accept what they're given. They have to impose on the people that are building the node software to say, you can't just go out there and build 1,000 chains. What you have to do is build 1,000 chains that I can get permissionless access to. Stop building all these thousands of chains because you're just creating a situation where you have all the data and I need it. That's not what we should be building. We should be building, you have all the data and you can't keep me from getting it no matter what you do. That access has to be built into the system. And
Well,
if
this
it's
is one of those things that what people are doing is there's like data availability on Ethereum, so you're eventually posting that data to Ethereum after some delay, and then theoretically you have access to it should it be on Ethereum.
well, in what way are they doing that with like blobs? Are you talking about or
Yeah,
something?
so this is the whole.
But that data is not really readable on Ethereum, is it?
It is. It's much. It's not nearly as useful as what you're building as far as the indexed stuff.
Right. So it's nice. It's nice that they push back this thing that they claim is, a proof that something happened, and that's great. Um, it's almost feels like it's part way the solution because if there's only 6 people who can actually read this and confirm that it's valid or something, that
Right.
feels weak. That feels weak to me, right? It feels. I was reading somewhere where some chain said, yeah, what the hell? We're not going to do that. We're just, the layer 2 just says we're not going to publish back to the
Right.
original. And they're like, and their community's like, oh, well, that's not good. And they said, well, fuck you, or something like that.
Well, I think this is always the question as far as like if you're creating an L2, are you they use the buzzword sovereign, like who has fork choice rule here? Is it if you're posting all the data back to Ethereum, theoretically, like you're not able to fork. Like this is the rules of the system, like the bridge almost is the system. But if if you're still able to fork and then change what data you're posting or go back and change history, are you an L2? And it's a super tough question because, even obviously, like, we started this conversation with the talk of the DAO, and the DAO would have rolled back some of this or changed it. But like, how do you feel about that in the sense of, like, that's okay as far as like how you're verifying it, and obviously more people are verifying it?
It's really a difficult problem because it's like, you either, it's really difficult. I always come back to the node software. Always. I always come back to the node software. That the people who are writing the node software have to put something in the node. Have the solution to the problem will always be in the node software. It will always be in the at the core of what the system does. It can't be something. I don't feel like to me. It doesn't feel like it can be imposed from the outside. To whatever's missing from the node software, which comes to consensus every 12 seconds or something, right? That coming to consensus, right? Permissionlessly, thousands of computers coming to consensus. Whatever's in that software, whatever's not in that software, gets built outside of that software. And now you have all of these problems.
Well,
And
like, basically, the more that's built outside, that's going to have efficiencies of scale. It's going to be sort of centralizing just due to market forces, and will get captured eventually until
yeah, because what happens is they put a layer around that central thing. They like stand between the users and the actual node software, and they control it.
Yeah, I mean, you see this with flashbots and with the whole builder market.
Totally. So to me, it always comes down to I have to run it on my computer.
Right.
I'm not saying that's how it's going to work. I'm saying that if it did work that way, I can see a solution. And if
Right.
it doesn't work that way, I don't really see a solution. You know? And in control I always go back to like when they changed I think it's called 1559, right?
Yep.
When they did that, that was the core developers just saying, okay, here's the rules. We're going to change the rules on the miners, and this is just how it's going to work. And they put a piece of code in the software that basically put in half the income from the miners,
Right.
or even worse, right? And the miners had absolutely nothing to say about it. So that's how we have to look at it like that, like the people who make the choices on how the software works have to impose on the L2s, I think. The system has to work in a way that's beneficial to the users, not to the providers, not to the people running the chains.
Right.
Because if it doesn't, it just metastasizes into Google. It turns into mega Google. And I think that's a bad choice. And the thing is, I see it coming. It's like every single day it gets worse. Every single day, the vision gets further away, it seems.
I'm gonna make you. Yeah, I do it with my daughters. You have to say something positive.
So, so they tell you?
No, I'm telling you that you have to be positive as we end.
In order, if your daughters hear me speak.
Yeah, no, and anyway, to end the, we're coming up on like an hour. We obviously see there's issues. One of the things I want to talk to you about is the first time I met you, we were both EF grantees back in 2018. You've been kind of doing, this has been all open source funding.
Totally. Yeah.
How do
Well,
you,
some of my own funding as well, but
Sure. I mean, how do you see this? How do you see the open source funding ecosystem currently? And, like, if other people are trying to build things like this that have more of a philosophical component and don't want to launch a token or have giant TVLs, what's the way to go about it?
well, first of all, you have to kind of look at what happened the last 4 or 5 years with the funding of open source. It's insane. I mean, it went from, I would say, basically zero. Like, where was there any funding for open source 5, 6, 7 years ago? None. And now it's like, stuff like the optimism retro funding is just insane. Like they funded me for a year, you
Yeah.
know, and they funded, and I was like I was in the top 100, and they funded me for a year. And it's like they funded 20, 30, 40, 50 projects for a year, right? That's really significant. And then you say, where does that come from? Why does that happen, right? Why? And it happens because we created something where people who write the software of how the system works make the decisions. It's not for the people. Those decisions are made for the community. The fact that we're going to take 20% of the optimism tokens and give it to open source projects is a choice that benefits the community of people. It's not a choice that benefits Google or Etherscan or these providers. I like always divide from the consumers and the providers. You don't want to fund the providers, right? You want to fund the consumers or the people or just the regular developers.
Right.
And that happened already. They funded 100 projects that for a year in open source. And I'm even like, I got some of this, I got some of these optimism tokens, and I'm talking to people that are not in crypto whose repos I'm using in my software. And I'm saying, can I give you some of this money that came to me because it was given to me to support my work, and I use your software. I want to give you some of it,
Right.
right? So that's profound. That's now whether it lasts, 6, 7, 10 years from now, I hope so. But it very easily could go away because it's kind of also at the same exact time crazy that they're giving away this money. It's like
It's a super cool trend, I think.
it's crazy, kind of like how can you defend giving away money? If you want to try to increase the value of your token, that's kind of the last thing you want to do, sort of. But I'm totally devoted to optimism, not because they gave me money. I believe in their mission and I believe in their ideas, right? I would accept the money, but I wouldn't become an adherent to them, right?
Sure.
If I didn't believe in them. But it's really profound. It's really interesting. And the same kind of thing happened with like the airdrops, 4 or 5 years ago, where you would get an airdrop of ENS because you were an early ENS user, or you would get an airdrop of Gitcoin or something.
Yeah.
Like that's something really different happened there. And that's the kind of thing that we want to not lose. And we will lose if we don't pay attention to that.
Well,
And
it was interesting because back then it was different. Like now everybody just is farming airdrops. So it's like, people are trying for them, but like, I know you and I got Gitcoin airdrops, but like you,
right.
you weren't trying for a Gitcoin.
Oh, not at all. I was just an early user.
Yeah,
You know?
exactly. Like
Yeah,
it was
yeah,
very different. Same with like, whether it was the Uniswap ones or whatever, like
exactly.
and I feel like we've lost like as soon as
Yeah,
you start measuring it and start paying and it's farmable, then it's like you
that's,
lose the core of it.
that's right. That'll happen to optimism, I'm pretty sure.
Yep,
Yeah. So, but it's profound. It's still profound. It's really, really interesting.
it is.
Yeah.
Um, Anyway, this was a super great conversation. I hope you had fun talking too. Um,
We talk way too much, but yeah.
yeah, where can people find out more? Where can people go to learn about you?
Trueblocks.io is our website, and we have repos. We have a couple different repos you can look at, and we have Discord that you can find through Trueblocks, and we're very happy to talk to anybody.
So when are you launching the browse?
Um, I No one knew about it until I told you an hour ago, and I wasn't intending to. So soon, someday, 2 weeks, 2 weeks.
So if you're watching this, keep it quiet for 2 weeks.
Yeah. Yeah.
Okay, will do. Thanks so much for coming on.
Nice talking to you.